of Engineering Mathematics 2. Today we will start the new topic, gamma function. Dear student, we know the integration of some standard function. Integration of your e raised to ax dx is e raised to ax upon a plus c, where c is constant of integration. This is some of the standard integrations. The gamma function is another type of integration in which we can find the integration of e raised to minus t, where t raised to some positive integer dt, its value in terms of factorial. So we can say that the gamma function is developed in the connection with the problem of generalizing the factorial function. That is, the problem of finding an expression that has value n factorial for the positive integer n. So let's start why we need the gamma function. The example of the simple integration e raised to minus t dt, a simple integration is defined here. We have to find a solution. First, we have to denote the given integration is equal to I. We denoted the given integration equal to I, and we can find the solution of such integration by using your by parts or the generalized theorem of integration. So one function is exponential and another function is my the trigonometric, another function is my algebraic equation. We know that if the algebraic equation and any function is multiplied and we have to find the integration, it can be found with the help of your generalized formula of integration. So with the help of your generalized integration formula, we can find the integration. The first function as it is, the t remains as it is here. We have to find the second function integration. Here exponential function integration is minus times e raised to minus t, and the first term is my positive, then second term should be negative, positive, then minus sign, derivative of your t is 1, and again integration of e raised to minus t of minus sign is e raised to minus t. When we replace your upper and lower limit, we can find the final solution of such a integration. Before putting the limit in the given terms, we have to make the simplification. The minus sign taken common, it becomes minus t, e raised to minus t. Again 1 into e raised to minus 2 becomes e raised to minus t. Putting your upper and lower limit, that is a infinity and 0, we can find the solution. So putting the value of your upper limit and the lower limit, we get this minus infinity, e raised to minus infinity, minus times e raised to minus infinity. We get the terms after replacing your upper limit, minus the lower limit value is put in the given expression. We know that the exponential function is running faster as compared to your algebraic function t. So the value of your minus infinity e raised to minus infinity is 0, because we know that the value of your e raised to minus infinity is equal to 0. Yep. From this, we can easily say that this particular first bracket becomes 0, minus and remains as it is. In second, 0 into 0 becomes 0, and minus e raised to 0 is becomes 1. So we get the final answer of this integration is 1. 1 means 1 factorial. In a similar way, when I increase the index of your t from 1 to 2, means this. Then according to the generalized theorem of your integration, we have to just take the integration. This is the first step. We have to just assume the given term as equal to I. T square remains as it is. And we have to just taking the derivative of your t square up to we get 0. In the first term, the derivative t square remains as it is. Second times it becomes derivative of your t square is 2t. And again, the derivative of your 2t is my 2t is again 2. And simultaneously, we have to take the integration of your second function. We know that the integration of your e raised to minus t is minus times e raised to minus t. Again, taking the derivative of these particular highlighted terms, its integration is again e raised to minus t, and minus sign occur 2 times, so it becomes positive. And again, we have to take the integration of this particular e raised to minus t terms. It becomes minus times e raised to minus t. Putting your upper and lower and limit. Before that, we are making the simplification, taking negative sign common. E raised to minus t square multiplied by minus sign, again minus 2. 2t e raised to minus t minus 2 times e raised to minus t. When we just put the upper and lower limit, so we get this particular. And again, we know that the exponential function is running faster as that of your algebraic function t. So the final answer of such integration is plus 2. Plus 2 in the sense it is a 2 factorial. What do you mean by 2 factorial? 2 into 1 into, actually 2 factorial means what? 2 into 1. Suppose I increase the index of t here. The index of suppose t, I increase and it just reaches to suppose 3. Then how to find a solution? Then we can find such integration by assuming the given integration is equal to I. My step number first. And again, we are using the generalized theorem of your integration. T cube remains as it is, and we have to differentiate the t cube up to its derivative becomes 0. And simultaneously, we have to integrate the e raised to minus t terms. The t cube, again, its derivative is 3t square, derivative again 6t, and next derivative is 6. At the same time, we have to take the integration e raised to minus t, whose integration is minus times e raised to minus t. Again, its integration e raised to minus t, its integration minus times e raised to minus t, and its integration e raised to minus t. And making the simplification, minus sign outside the bracket, multiplying the minus sign, we get this. Putting upper and lower limit, we know that the exponential function is running faster as compared to your trigonometric algebraic equation. So the first bracket becomes 0, and the second brackets we got only 6. And we know that 6 can be expressed 3 factorial. 6 can be expressed 3 factorial. In the similar way, we observe here, if the index of t is suppose 3, then we get 3 factorial is my solution. In the similar way, suppose I increase the index of your this t, suppose it is 100, then it should be 100 factorial. When we observe this integration, the integration runs from 0 to infinity. The exponential function index is minus t raised to 100 dt is nothing but 100 factorial. This is the expression we can find its value in terms of factorial. So this is the definition of your gamma function. Suppose we change the variable of your integration from t to another variable. Here, instead of t, suppose I say it is suppose x, and x whose index here x, and integrations variable changes. The answer is remains same. It means in the gamma function or in this integration, the variable is a matter. Means whatever variable you used or we used, that is a matter. Instead of x, I use y, I use z, I use any another parameter. It depends on that. This is the value of the integration in terms of factorial. And we can use the generalized rule for if the n is my positive real integer. Then and then we can find the integration. Otherwise, what? How to just know the solution of such a function? The index of your this is the another example. Solution of this example is 4 factorial. So no need to just this is the first step. Second step is we have to just take the integration. After just integrating, just we have to just take the minus sign common, or we have to make the rearrangement of terms, putting an upper and lower limit. We get a final answer is 24, and 24 is nothing but the 4 factorial. 3 into 2 into 1 into 4, or we say that 4 into 3 into 2 into 1 is the solution of such an example. The similar in this way, what we say, we can find the solution of, in general we can say this is the condition. Means if the index is 3, its answer is 3 factorial. Its index is 100, its answer is 100 factorial. Its index is suppose 10, its answer is 10 factorial. So this is the integration in which we can find its solution very easily when the index of your t is the positive real number. Then and then we can find the integration. What happens when the integration value is get changed? Suppose I say that it is 1 upon 100, 1 upon 10. Then what is the solution? It's a question mark. This is the definition of your gamma function. Whatever index of your x, we got some real value, and that real value can be defined with the help of the formula, and that is said to be the gamma function. So we will just see the definition of your gamma function. A definite improper integral. See here the integration type is, the integration runs from 0 to infinity, e raised to minus x, x raised to n minus 1. I already defined the variable is a matter. We can find the integration of such a particular terms. It is denoted by the symbol just gamma of n. That is this is the symbol of your gamma function, gamma of n, and it is called gamma n, or Euler's integral of second kind, or simply we say that it is an improper integral. So the definition of your gamma function in the form of integration, the gamma of n is equal to integration 0 to infinity e raised to minus x, x raised to n minus 1 dx. This is the definition. When we observe that the index of your x is n minus 1 and it is converted into your n. And similar definition here, we changes the index of your x. In the first integration, the index of your x is minus n minus 1. We are changing the index from n minus 1 to n. So we get the new definition of your gamma function. The gamma of your n plus 1 is equal to integration 0 to infinity e raised to minus x, x raised to n dx, where your value of your n is greater than 0. So this is the definition of your gamma function. So we can find the solution of the gamma function very easy. For example, suppose this is, suppose n is equal to suppose 9. That is suppose 9. Then what we got? The gamma of 9 plus 1. The gamma of 9 plus 1 is equal to what? It is a gamma of 10. We say that is equal to, it is 10. Then how to find the value of this gamma? What is mean by the gamma? The gamma defines some standard properties according to its definition. So we will see the some properties of your gamma. So gamma defines some standard properties. The first property, the gamma of 1 is equal to 1. Gamma of 1 is equal to 1. It means it is 0 factorial. It is equal to 1. We will see the next property. Gamma of 0 is equal to infinity. We don't know the value of your minus 1 in minus 1 factorial. And it is a very, very, very important rule to find the value of your gamma of your n plus 1. The gamma of n plus 1 is equal to n times gamma of n. Means we have to just subtract 1 from this n plus 1. We got n. This n is multiplied to your gamma of n. N into n gamma. In the similar way, when we just change the value of your n plus 1 in terms of n. So gamma of n is equal to n minus 1, gamma of your n minus 1, where n is fraction. Fraction means it is a positive integer. It is positive integer, then we can find the value of your gamma with the help of this formula number. Again, the similar way, the gamma of your n plus 1 is equal to n factorial, or the gamma of your n is equal to n minus 1 factorial. It is for if my n is my positive, we said that real number. Real instead of number, instead of integer, we said that it is a real number. What is my real number? Then we can convert the n plus 1 into directly n factorial, or gamma of your n is in terms of n minus 1 factorial. And gamma of your 1/2 is equal to root pi. The standard property of your gamma of 1/2 is root pi. And the next, integration 0 to infinity e raised to minus kx raised to n minus 1 dx is equal to gamma of your n divided by k raised to n. So we will prove this property in next few lecture. Property number 7, the gamma of p into gamma of 1 minus p is equal to pi upon sine p pi, where the value of your p should be greater than 0 and less than 1. The next property, the integration goes from 0 to infinity, x raised to n e raised to minus x raised to m dx is equal to 1 upon m, gamma of your n plus 1 upon n. So we will prove this property. And again, the gamma of your n is equal to 2 times 0 to infinity e raised to minus x square x raised to 2n minus 1 dx. This value is also nothing but gamma of n. And lastly, the integration 0 to infinity e raised to minus x raised to n dx is equal to 1 upon n, gamma of 1 upon n. This is the property. And one important note, if we have to find the value for a gamma of some odd number upon 2, it can be just find with the help of this simple formula. We have to subtract the even number from the odd number which is present here. Odd upon 2, odd minus 2 divided by 2, odd minus 4 divided by 2, odd minus 6 divided by 2, up to we get 1/2. And this particular solution is get multiplied by root pi, because root pi here gamma of 1/2 is present. These are some properties. We will see some example to understand the concept of all the properties. Example number first, we have to find the value of your gamma of 5/2. We have to find the value of your gamma of 5/2. Then we know that we already saw the properties. The gamma of gamma of n is equal to n minus 1, gamma of your n minus 1. Here value of your n is equal to what? 5 by 2. So gamma of 5 by 2 can be expressed replacing the value of your n is equal to 5 upon 2 in this particular formula. We get gamma of 5 by 2 is equal to 5 by 2 minus 1 and gamma of your 5 by 2 minus. After subtracting your minus 1, subtracting 1 from your 5 by 2, we get is gamma of 5 by 2 is equal to 3 by 2 gamma of 3 by 2. Again, the 3 by 2 is in terms of gamma. So we have to use again the same rule, same formula here. Gamma of n is equal to gamma n minus 1 multiplied to gamma of your n minus 1. So we get gamma of 5 by 2 is equal to 3 by 2. Again 3 by 2 minus 1 and gamma of 3 by 2 minus 1. Making subtraction, it is 3 by 2, 1 by 2 and gamma of 1 by 2. And we know that gamma of 1 by 2 is nothing but root pi. So we get 3 upon 4 into root pi is the solution for a gamma of 5 by 2. We will see the second example of the same type. 7 by 2. And we know the standard formula or standard conversion of this. We have to subtract the even number from 7. That is either from the numerator. We have to find gamma of 7 by 2. And we know that the property of gamma of n is equal to n minus 1, gamma of your n minus 1. With the help of this, we replace, or we can say that we have to use the formula. Which formula? This formula. We can use this formula here and directly find the solution. Here, odd number upon 2. 7 is my odd number, 2 divided by 2 is here. So we have to subtract the 7 minus 2. It becomes 5. 7 minus 4, it becomes 3. 7 minus 6, it is 1. And lastly, we have to multiply by root. Means we have to subtract the even number from the numerator, that is an odd number, up to we get the subtraction is equal to 1. So we get the subtraction of your 7 by 2 is 5 by 2. 7 minus 2 upon 2 is 5 by 2. 7 minus 4 upon 2 is 3 upon 2. And 7 minus 6 upon 2 is 1 by 2 into root. And after making the simplification, 5 into 3 into 1 is 15. 2 into 2 into 2 is equal to 9. In a similar way, we can find the value of your 9 by 2, 11 by 2. Suppose 11 by 2, we have to subtract 2 from your 11, it becomes 9. Then second odd number 7. And then next odd number is 5. Then our next odd number is 3. We get 1/2. And making the multiplication of such a ratio, we get 945 upon 32 root pi. We can find the gamma of another terms or another example of this same type, 15 by 2. This can be find the next example is gamma of 7 by 3. In this case, we cannot use the formula for odd number minus 2 because the divided by term is here 3. So simply we are using the formula, that is a gamma of your n is equal to n minus 1, gamma of n minus 1. So gamma of 7 by 3 can be expressed 7 by 3 minus 1 into gamma of your 7 by 3 minus 1. It is my 4 by 3. And again, gamma of 4 by 3 is 4 by 3 minus 1, 4 by 3 minus 1 of gamma. And it is the last step 4 by 3, 1 by 3, 1 by 3. If the value of your numerator is less than the value of your denominator, so we have to stop the calculation of your gamma. In such a case, it is here gamma of 1 by 3 means 1 is the value of your numerator and 3 is the value of your denominator, which is greater than 1. So we cannot use the gamma function. So we get the negative value. So we have to stop the calculation here and find the final solution. So 4 into 1 becomes 4, 3 into 3 becomes 9, and gamma of 1 by 3 remains as it is. These are some examples in terms of integers, and we have to just take the example of positive real numbers. So 100, gamma of 100, we have to use the property that is a gamma of n is equal to n minus 1 factorial. Value of n is equal to 100, so it is a 99 factorial. So gamma of 1 is equal to 1 factorial. We already saw that the property, that is gamma of 1 is equal to 1 minus 1, that is a 0 factorial, and the 0 factorial value is equal to 1. Next one, 7 factorial, its value should be 6 factorial, and 6 factorial in the sense 6 into 5 into 4 into 3 into 2 into 1, and we get a final solution that is a 720. Next, the last example, that is we have to find the value of your 1 upon 4 into gamma of 1 by 3 by. So we have to convert this example into this. The gamma of n is equal to gamma of n minus 1 factorial is the final term, but the example is in the form of positive integer. So we cannot apply this rule. So we have to use again this one. Gamma of n minus. This is the property we have to use to find the solution of this. So we can convert the given example in this form. So 1 upon 4, its gamma, into 3 upon 4, its gamma, can be expressed in the form of gamma of 1 by 4 into 1 minus 1 by 4. Means this 3 by 4 can be expressed in the form of 1 minus 1 upon 4. And this is converted into property gamma of p into gamma of 1 minus p, and its answer is pi upon sine p pi. So when we observe here, the value for p is equal to 1 by 4. When we observe carefully, the gamma of p into 1 minus p, the value for p is equal to 1 by 4. So we have to put the value for p is equal to 1 by 4, and this we get a final solution. This is the solution of CL. We have to replace the value of your P here. The value for P is equal to pi by 4. And final, we get a solution. 1 by 4, 3 by 4 is nothing but it can be expressed in the form of 1 minus 1 by. And we know that sine pi by 4 is equal to 1 upon root pi. And lastly, we have to simplify. So we get the final solution, that is root 2 pi. So in this way, we can find the solution of your gamma function with the help of property, with the help of definition. We can find the value of gamma function. Thank you. We will see on next lecture.